Hi students, today I have come up with one more interesting topic from the gaseous state, that is concept of open vessel. Means how to solve the questions when you are given with a open vessel. So just look at this problem. An open flask or the vessel. An open flask contains air at 27 degrees centigrade. To what temperature it must be heated to expel 1/4 of air? Means here first you have to know what is the concept of open vessel. So here it is a open flask and it is at 27 degrees. So T1 is equal to 27 degrees plus 273, which is equal to 300 Kelvin. And at what temperature it must be heated? Let the initial moles of the gas be 1. Means N1 is equal to 1. Here on the open vessel, here we are heating, means here we are supplying some amount of heat. So as you are supplying amount of heat, here there is an here, and also to what temperature it must be heated to expel 1/4 of its air. When you are heating, how much of the gas is escaped into the environment? Means it is 1/4 of the gas which is escaped into the environment. Now what are the remaining moles? 3/4. Now here in the concept of open vessel, volume is constant because it is volume of the container which is constant, and pressure is also constant for the open vessel because as it is a open vessel, what is the pressure operating on this vessel? It is the atmospheric pressure, so which is a constant. And the number of moles, N, there is a variation in the number of moles because here initially we have taken 1 mole and 1/4 of air has expelled by the application of temperature. So what are the variables here? Number of moles and temperature, and R is universal gas constant. So if you apply ideal gas equation, which is PV is equal to nRT, here what are the terms constant? These two are constant and R is an universal gas constant. Now what will be the formula for the calculation of this one? N1 T1 is equal to N2 T2. So N1, it is the number of moles which is 1 and it is 300. And what is N2? What are the moles remaining? It is 3/4, and you have to find out T2. So at what temperature it must be heated to expel 1/4 of air? Okay, it is the concept of open vessel when you are given with open vessel problem. So first keep in mind that volume is constant because volume of the container is always constant, and here pressure, atmospheric pressure, which is constant. So here what are the variables? Number, as you are supplying the temperature, there is a variation in the temperature, and by taking temperature some of the gas will be expelled into the environment. So variation in the number of moles. So what are the moles remaining? 3/4. So what is T2? T2 is equal to 300 into 4/3. So which is equal to 400 Kelvin. So minus 273, you will get answer in degrees. Okay, now another problem from the same concept, open vessel. An open vessel at 27 degrees is heated until 3/5 of air is expelled. Until 3/5 of air is expelled. Assuming, here as given, assuming volume of the vessel remains constant. As we all know, as it is an open vessel, volume always constant. And find the temperature to which the vessel has been heated. So for the open vessel, pressure constant, volume constant. So by applying the same formula, N1 T1 is equal to N2 T2. Simple. So let the initial moles be 1. So what is N2? Initial moles minus 3/5 of gas is expelled. So which is equal to 2/5. So what is N2? It is 2/5. And T2 you have to find out. And T1, it is 27 again plus 273, it is 300. So what is the value of T2? T2 is equal to 300 into 5/2. 3 5 15, 750 Kelvin. Okay. That's it. I think by watching this video, the concept of open vessel is clear to you. Okay, thank you.